Hello children, how are you? Good? Nice to meet you. Children, hope you all are safe and staying at home. I know you all are giving your assignment, but please children, side by side start mugging up your lessons. Okay, let's start our new lesson.
One, matter. I know you have already studied this chapter through the video on YouTube which I sent with second home assignment. But now I am again explaining this chapter so that you can clear your doubts if any. Right children? All of you know, if we look around us, we see number of things like book, chair, pencil, table, sand, soil, air, water, clothes which you are wearing, food which you eat, all are made up of different types of materials and are called matter in science. So, question is, what is matter? Matter is anything that occupies space, has mass and can be perceived by the senses. Right? Now, in this way we can say that matter covers all the substances and all the materials from which the universe is made of. Now the question is, what is the composition of matter? Now matter is made up of what? It is matter when either it is found in solid state or liquid state or gaseous state, is composed of small particles. In these particles may be molecules or atoms or ions. Now next is what is an atom? An atom is the smallest particle of an element which can take part in a reaction and is considered the basic unit of matter. Now hydrogen, H is one atom of hydrogen. O is one atom of oxygen. Cl, one atom of chlorine. Right? Now next is your molecules. Now what is a molecule? A molecule is the smallest particle of a substance that can normally exist separately and retain the characteristics of the substance. Children, just remember, atom is the smallest particle of an element, while molecule is the smallest particle of a substance which can retain the characteristics of the substance. Right? Now just see, one atom, this is H, is one atom of hydrogen. When combined with another atom of hydrogen, it forms one molecule of hydrogen. Right? The same way, when two molecules of hydrogen combined with one molecule of oxygen, it gives two molecules of water. If I write this H2O, H2O, what is it? It is one molecule of water. What is it? One molecule of water which is made up of two atoms of hydrogen and one atom of oxygen. Now next is your ions. An ion is any atom or a group of atoms which has a resultant charge due to loss or gain of electrons. Due to loss or gain of electrons. Means when one atom of hydrogen lose one electron, it is converted into H1 positive ion. So what is it? It is one ion of hydrogen. The same way, when oxygen atom gain 2 electron, it is converted to O2 negative, and O2 negative is one ion of oxygen. Right children? Now next is your characteristics of matter. Now matter is, all of you know, matter occupies space. And what is this space? It is called volume. Now matter has mass. What is mass? The quantity of matter represents its mass. And naturally matter has what? Gravitational, it has a weight. So the gravitational pull on matter represents its weight. Right? Matter can be perceived by the senses, right? And perceived by the senses means either you can touch it, or you can see, or you can smell, or you can feel. Now matter may be living or it may be non-living. Living matter includes your plants, animals, human beings, and non-living matter includes air, water, soil, sand, stone, etc. Right, children? Now next is your states of matter.
This is what happens in the three states of matter. In solids, the particles are packed together very tightly. They are very close to each other. In liquids, the particles are not as tightly packed to each other as in the solid state. The spaces between them are a little more than the solid state. And in the gaseous state, the particles are quite far away from each other. The spaces between the particles is much more as compared to the liquid and the solid states. Let's recall the kinetic theory of matter, the postulates that we've studied. So we know the particles of matter are very small. They have spaces between them, which we call interparticle or intermolecular spaces. The particles always attract each other by a force known as intermolecular force. And the particles are constantly moving. These are the postulates of the kinetic theory of matter. And this theory holds true for the three states, that is the solid, liquid and gaseous state. Based on this theory, we get the kinetic model of the three states. So this is the kinetic model of the solid state, according to which the particles in the solid state are very close to each other and they vibrate about their mean positions. So let's see. Since the particles in a solid state, they are very close to each other, the intermolecular spaces between them are very small, and that is why they attract each other. That is, the intermolecular forces between the particles is very strong. So in solids, the intermolecular spaces are small. That is why the intermolecular forces are very strong. Let's see the kinetic model of a liquid state. So this is the kinetic model of a liquid state, in which the particles are not as close to each other as in the solid state. They are able to move a little more freely than in the solid state. So this is what we get for the liquid state. In liquids, the spaces between the particles are larger as compared to the solids. So the intermolecular spaces for liquids are larger as compared than solids. And that is why the intermolecular forces, that is the forces that attract the particles to each other, are weaker as compared to solids. In solids, since the particles of a liquid are away from each other, not as close to each other as in solids, that is why liquids do not have a definite shape and they flow. That is why liquids are known as fluids. Let's see the kinetic model of gaseous state. We know in the gaseous state, the particles are freely moving. The spaces between them are very large. So the spaces, the intermolecular spaces between the particles of the gaseous state are very large. That is why the intermolecular forces between the particles of matter of the gaseous state are very weak. The gases have a very weak intermolecular force of attraction. So here we'll perform an experiment. We'll try to check for the compressibility of the three states. In the first test tube, we have a solid piece of wood. In the second test tube, we have a liquid, in this case water. And in the third test tube, we have a gas which is enclosed in the third test tube. They're all cogged initially. Now we'll try to compress them. We'll bring a piston and we'll see how much are we able to compress these three states. So let's see. We first compress the gaseous state. You see that it is compressed to a great extent. Now the solid and the liquid state. So you see that for solids, the compressibility is negligible. The piston does not move at all. In case of liquids, the compressibility is a little more as compared to solids. The piston moves a little down, and in the gaseous state, you see the greatest compressibility. You can compress the gases to a very large extent. Why is this happening? This happens because right now we saw the kinetic model of the three states. In the gaseous state, the particles are very far apart from each other. They have a lot of intermolecular space. So when we compress them, these particles occupy the spaces, the intermolecular spaces, and that is why we can compress them. But in case of solids, we know that the particles are very tightly packed to each other. The intermolecular spaces are negligible. That is why when we try to compress them, there is no space that these particles can occupy, and that is why the solids have negligible or the minimum compressibility. So the compressibility for solids